Welcome back all of you. So, in the last lecture we have discussing about the interpretation of triaxial test, and we have finished UU test and UCS. In today's lecture we will see the interpretation of consolidated undrained CU test. Okay. So, let us start the consolidated undrained CU test. Now, in this, as different from UU test, we have to understand that the consolidation at every confinement alters the initial effective stress condition. What does this mean? We need to understand, because while learning this we might not have paid much attention to what is the implication of consolidation. Now, what happens during consolidation? We are conducting the test at least maybe 3 different confinement or sigma 3 values, and at every sigma 3 for CU test we allow drainage to happen and the consolidation to occur. Now, this consolidation alters the initial state of the sample, which was not happening for UU test, and when the initial state alters, definitely the strength of the soil will differ. Now, what is the significance of this statement? When the strength of the soil differ is, in terms of Mohr circle, the diameter will keep changing, which was not the case for UU test. So, that is the significance of what is meant by consolidation at a given cell pressure. Now, the second part of this test, that is the shearing part, is at undrained condition. Now, during undrained condition, pore water pressure will develop, and the same is measured in this particular test. So, due to this U measurements, we can present the result in terms of both total as well as effective stress. Now, just like we discussed about the stress condition in the soil for UU test, we will see what is the stress condition in CU test. So, first is saturation stage. Again, for each of these tests we will repeat these, because for completeness and for clear understanding. So, we need to ensure that the B parameter is greater than 0.95 to ensure that it is fully saturated. So, next stage is consolidation. Now, consolidation can be brought about or saturation can be brought about by the application of back pressure as well, and we may also not opt to take the back pressure. So, there are 2 conditions of consolidation where back pressure is used, where back pressure is not used. So, first let us see a consolidation stage without back pressure. Okay, so, this is the confinement application. This particular sample is denoted in general, that is sigma VC, that is the vertical stress for confinement. C denotes confinement, and sigma HC is the horizontal stress for confinement, that is sigma HC. Now, there can be isotropic or anisotropic consolidation. In general conventional triaxial testing, we always opt for isotropic consolidation, because this is more simple and easy to understand. Anisotropic consolidation would also induce some sort of shearing, because there is a difference in stress. So, here we are talking about a condition where sigma Vz equal to sigma Hc, which is an isotropic consolidation. Since it is a consolidation stage, drainage valve will be opened and we do not expect any pore water pressure to develop. So, the pore water pressure will be equal to 0, because of consolidation stage. Okay. If there is some residual pore water pressure, we need to account for that. That will be the initial pore water pressure, that is soon after it is mounted. Okay. So, in this consolidation stage, since the drainage valve is opened, pore water pressure is equal to 0, and hence we have sigma Vc equal to sigma V dash C, and sigma Hc is equal to sigma dash Hc. So, that is consolidation stage without back pressure. Now let us see the consolidation stage with back pressure. So whatever we are doing this isotropic consolidation, this may not be actually realistic in the field, because in the field always anisotropic consolidation happens, because you have an overburden. Because of this overburden, there will be lateral earth pressure. Lateral pressure is not always equal to vertical pressure. Hence, what we are adopting in triaxial testing, we need to understand that there is some deviation from the reality, and hence, but we still go ahead because this is very easy to understand and follow, and there is no shear which gets induced. So total stress, what did we understand in back pressure? In back pressure, both the cell pressure and the back pressure is increased simultaneously. So it is more like a static pore water pressure. That is what is denoted here. So sigma Vc is raised by UBP, and sigma Hc is also raised by UBP, and but here it is isotropic consolidation, and the pore water pressure within the soil is also increased by back pressure. So UBP will be the back pressure, pore water pressure. So what has happened? UBP is increased outside and there is an increase in inside also. So net effect is 0. So effective stress is sigma V dash C and sigma H dash C. Now in the previous case also, that is when back pressure is not applied, then also the sigma V dash C and sigma H dash C is the same. So we are not altering the initial effective stress condition. So once the consolidation is completed, that means there is no more drainage of water happening, then the next stage is shearing stage, and this is done under undrained condition. So here we are increasing by delta sigma, that or the stress difference, or whatever is the axial stress which is imparted to the sample, that is delta sigma. Now this results in an increase in or decrease, there is both positive and negative of pore water pressure during shearing stage. So during shearing stage there is either positive or negative pore water pressure. Now why this positive or negative pore water pressure? We can see that it depends on the tendency of the sample to contract or dilate. Let us say that there is a volume change which is permitted for this particular sample. Now during volume change, what happens to this soil during shearing? We have seen this in our previous lecture, that this sample will have a tendency to either compress or it to dilate. So that is the volume change. In this case volume change is not permitted, so that translates to pore water pressure. So a dilating sample will try to exhibit negative pore water pressure or decrease in pore water pressure, whereas a compressing sample, those sample which tends to compress will achieve positive pore water pressure, because drainage is not permitted, it translates to pore water pressure. So hence the effective stress will be sigma Vc plus delta sigma plus minus delta u. So this sign depends upon the behavior during shearing. Similarly for sigma Hc. So this is the stress condition of the sample during consolidation and during shearing stage. Here we there is also important aspect which we need to understand, which we know, but it is better that we confirm this again and again. So sigma cell pressure is equal to sigma Vc equal to sigma Hc isotropic consolidation, which is equal to sigma dash 1c sigma dash 3c, provided pore water pressure is 0, and sigma 3 dash c is equal to sigma 3 f, that is only in terms of total stress. But since the shearing stage is undrained, there will be pore water pressure that gets generated. So definitely the final cell pressure is going to be different, that is final effective cell pressure, that is sigma dash 3f, which is sigma 3f plus minus delta u. So that is why this is not same, and the final deviatoric stress at failure will be sigma 1 minus sigma 3 of UF. Now, let us see the typical stress strain response of CU test. Now, we have already discussed in our previous lecture about a typical stress strain response. Now, there is nothing different from that when you consider UU, CU or CD test, but it is important for every stage of the test that we repeat this and reaffirm that this is what is the stress strain response. Why this is important is this knowledge is very much important for your subsequent modules. So, there is no harm if we hear this maybe 1 or 2 times more, so that things and the concepts will be pretty clear. So, here it is deviatoric stress versus volumetric strain, and a typical OC, NC and LOC curves are given. This we have seen previously. Here it is plotted in terms of volumetric strain. One can do that in terms of axial strain as well, and volumetric strain is epsilon A plus 2 epsilon R. So, what is happening? A typical OC has a peak and NC does not exhibit a peak, and here it is strain softening, here it is strain hardening. Now, in this case, instead of volume change, we have changes in pore water pressure, and if it is under back pressure, then the pore water pressure starts from the back pressure, and for NC there will be positive. So, this will be positive and that is NC, and for OC after a small initial adjustment it will get to negative pore water pressure. So, that is what is going to happen. It may reach negative, but what it means is that it is reducing, the pore water pressure is reducing from back pressure. Okay. So, depending upon the amount of OCR, that means how over consolidated the soil sample is, maybe it is heavily over consolidated. So, definitely it may reach to a negative pore water pressure. So, the same figure is plotted in terms of principal stress ratio. This also we have seen before as a very important aspect, in terms of maximum stress obliquity. So, sigma 1 dash by sigma 3 dash versus epsilon V, it gives the same pattern as that of the deviatoric stress pattern. Only thing is the peak, it may not be exactly at that particular point because of sigma 1 dash by sigma 3 dash. Please note it is in terms of sigma 1 dash by sigma 3, that is effective stress ratio. Here in the case of deviatoric stress ratio, sigma 1 dash minus sigma 3 dash is equal to sigma 1 minus sigma 3, it is same. So, in the ratio maybe there will be some difference here and there. So, that is why the trend is same, but it may not be exactly the same. Here it is starting from 1, why? Because we are starting from an isotropic stress condition. So, OC exhibits softening behavior, NC exhibits strain hardening, delta U increases for NC and decreases for OC. Principal effective stress ratio exhibits similar trend like deviatoric stress. Now, let us see the typical Mohr circle for CU test in the case of NC and OC. So, for the NC case, the total stress circle, that is at the end of the test, like once the test is completed we obtain the failure stress, then we try to plot the Mohr circle. So, the total stress circle is indicated and a failure line for total stress is indicated, that is phi t. So, we have already measured pore water pressure, and measurement of pore water pressure is invariably necessary in the case of CU test. So, once we know UF, that is a pore water pressure at failure, one can plot the effective stress circle. So, this is the effective stress circle. Now, if we draw the failure envelope, that is given by phi dash. Now, what is the implication of this line and this line? Let us see. Based on failure stress obtained from triaxial test, we have plotted this plus U, because U shifts the effective stress circle towards origin, because we are minusing from the total stress. Same diameter for effective and total stresses because sigma 1 dash minus sigma 3 dash is equal to sigma 1 minus sigma 3. MC failure envelope passes through origin. Now, this is a very important information which you have to keep in mind. Let us say that you are dealing with normally consolidated clays, and if we have certain wrong notion that clays are always cohesive material, then we tend to question the fact that why there is no cohesion and there is only friction, which may be sometimes difficult to understand. We need to understand that all soils are granular in nature and it can mobilize friction. Now, what happens to a normally consolidated material? A normally consolidated material, it can undergo fast volume change, and here in fact it is in terms of pour water pressure because volume change is not restricted. So, you tend to have only frictional component for normally consolidated clays, and we do not tend to have cohesion for this particular soil, and hence the failure envelope of Cu for NC passes through origin. So, that we need to keep in mind, and phi t is less than phi dash. Now, let us try to understand whether this is really important or not, whether phi t, that is the frictional angle corresponding to undrained condition, is it relevant or not. In fact, it is not relevant. The reason is Mohr Coulomb failure envelope is always defined in terms of effective stress. So, only this particular failure envelope is important, and we generally do not use phi t because the undrained strength is different. Now, we will keep repeating this. You will hear the statements at least 4-5 times throughout this module, and we need to clearly understand this particular fact. So, for OC, the total stress circle is given as follows, and phi t is drawn, and you can see that it does not pass through origin. So, here since the soil has the tendency to dilate, the pour water pressure will be less. So, it will tend to be negative, and hence we will have effective stress circle moving towards the right and the failure envelope drawn as phi dash. So, U decreases and may become negative, shifts the effective stress circle towards right, same diameter, same explanation. MC failure envelope does not pass through origin. For OC, which means that a cohesive component may exist. Now, this may be due to cementation, this may be due to apparent cohesion. It is not very clear since the particles are already stiff, because it is over consolidated and the stress which is applied is less than the over consolidation, the pre-consolidation stress. The material tends to act like a stiff material and the particles are sufficiently close. So, this would exhibit in terms of some sort of cohesive intercept that you get. So, for OC cohesion may exist and phi dash would decrease. Now, phi dash decrease means in terms of NC and OC, do not think that OC will have a lower strength, it is not like that. So, when you plot the envelope for both, then we will be in a better position to understand. So, for OC cohesion may exist, phi dash would decrease, that is phi dash is less than phi t. Again phi t does not have much meaning. Mohr circle for Cu test for a wide range of normal stress. Now, just we will try to understand what is the kind of Mohr circle when we consider a wide range of consolidation stress or normal stress. So, tau versus sigma. Let us first draw the pre-consolidation pressure. Sigma dash p is the pre-consolidation pressure which divides the behavior into OC and NC. So, let us say the total stress circle for NC, which gives phi t, and this passes through origin. The effective stress circle and the envelope, the failure envelope, which is denoted by phi dash, this also passes through origin. Now, for what is alpha f? Alpha f according to Moore's failure hypothesis is the inclination of failure plane, which is nothing but 45 plus phi dash by 2, and that is as per the Moore's failure hypothesis. Now, total stress envelope for OC is T, and if you draw it, you can see that there is a kink or there is a discontinuity at this point P. Now, this point P is roughly 2 times sigma dash P for typical clays, and this information is obtained from Halls and Kovacs. The original paper is different. If you are interested to find out more, you can always refer to this book and cross refer the literature. The effective stress circle for OC is drawn and the failure envelope is drawn. In both these cases, there will be sort of cohesive intercept. Now, failure, again this part is, I am telling this again repeated, and I am intentionally repeating these statements so that it is pretty clear as to what we tend to understand. So, and this understanding again, it is important for accumulating your further understanding. So, failure is fully governed by effective stress. MC failure envelope is valid only in terms of effective stress, that is long term. Short term strength is only in terms of undrained cohesion. So, phi t does not have much relevance with respect to Moore Coulomb failure envelope. Now, what is the relevance? We will not talk about phi t much. The reason is, for failure, defining the failure bound, we tend to use only effective stress, and hence Moore Coulomb failure envelope in terms of effective stress only is important. Now, what is the relevance of CU test? It is used for stability problem where consolidation already occurred and further developed an undrained condition. For example, this is a typical case of an embankment construction. So, this is, let us say this is a clay, and consolidation already occurred when you constructed this particular one. So, it is a kind of staged construction. The entire height of the embankment is not constructed in one go. First, this part is constructed and it was left for some time before the second part got constructed. So, this particular clay would have undergone some amount of consolidation. Maybe it might have undergone a complete consolidation depending upon the clay properties. Then comes the construction of 2, and this construction of 2 induces again a undrained condition provided clay is saturated. Now, this is a typical case of CU condition. Some other conditions are rapid drawdown of embankments, slopes of reservoirs. Now, when there is full of water and then there is a rapid drawdown that is happening, that induces more effective stress, and this additional effective stress is going to cause an undrained condition within the core of the dam. So, I am not going to the details of it. I just need to understand that these conditions do exist and it is close to CU conditions, and this is very true with clays where undrained conditions are common. Another case where such a case can occur is when you are constructing an embankment over a natural slope. So, in case of certain developments, if it is done, then this can undergo a kind of CU response. Let us just try to see quickly what is the significance of what we have just understood. NC clay is subjected to CU test. The soil sample is consolidated under isotropic stress of 150 kilopascal. The principal stress difference at failure is 100 kilopascal. What is meant by principal stress difference? That is deviatoric stress at failure. Poured pressure at failure is 88 kilopascal. what is the shear strength parameter for this soil. Nothing is told about back pressure, so we will not get into that. We will assume that the pore water pressure is the final pore water pressure at failure, and whatever it is all inclusive. Now, based on effective stress principle, shear strength is governed by effective stress. What is given? Sigma 1 minus sigma 3 F is 100 kilopascal, UF is 88 kilopascal, sigma 3 C is 150 kilopascal. So, this much is given, and these are in terms of total stress. So, sigma 1 F, that is from this particular equation one can find out what is sigma 1 F, that is equal to 250 kilopascal. You are just adding sigma 3 C to it, and sigma 1 dash F is minus pore water pressure, that is 162 kilopascal, sigma 3 dash F is equal to 62 kilopascal, and for NC cohesion is 0. Now, think of a situation that we do not understand this particular point, like for NC there is no cohesive intercept, then it becomes difficult to solve this problem. So, now we know that NC does not possess cohesive intercept. So, that is equal to 0. If that is equal to 0, then one can always write the Mohr Coulomb failure envelope sigma 1 dash F is equal to sigma 3 dash F tan square 45 plus phi dash by 2. Substituting the effective stress condition into this equation, we can get phi dash is equal to 27 degrees, and that is plotted as follows, and this is the bound. This particular line is the bound. Now, only one Mohr circle is there. If you have more or 3 Mohr circles, as we do for the triaxial testing, an average line which is tangential to 3 of the Mohr circles gives the failure bound or Mohr Coulomb failure bound or failure envelope. We can also obtain the value of phi, that is phi t, if you substitute the total stresses in the same equation, which is not relevant, but if you substitute you will get 14 degrees, and that is what has been plotted here. Now, that is the difference is UF. Now, for design consideration 27 degree is useful, and this phi t equal to 14 degrees may not be useful. I am telling in terms of the failure criterion and the failures or the strength parameter. So, CU test is a relatively quick test which can be used to determine Mohr Coulomb failure envelope shear strength parameters. So, what we are doing here is, we know that for clays drainage is poor and it takes weeks or maybe even months for completing a consolidated drain test if we are conducting it with a condition that pore water pressure does not generate. So, practically it is not possible for conducting a drained test in clays whose permeability is less. So, in that condition we have a CU test where it is still faster. Why? Because the shearing stage is undrained. But there is a problem associated with it, which is like in CU test the rate of shearing is faster. I mean the second stage the rate of shearing is faster, and which is different from a normal field case or a CD case. Now, we also need to understand that the rate of shearing considerably influences the strength. Hence, what we get from CU, that is from CU we do the test, get the result in terms of effective stress. This effective strength parameter closely simulates, but we need to understand that it is not exactly what is expected in the field. The shear strength parameters obtained from CU based on U measurements may not represent the actual long term conditions in the field. This is exactly what I just told, because in the field it takes time, in what manner it is getting loaded and in what rate it is getting loaded, and in what rate the pore water pressure is dissipated and it gets to drained condition. These things are quite different from what we simulate in the lab, and that is the reason why we need to understand, like we will use CU parameters, effective strength parameters, but we need to understand that there will be some sort of deviation. What we are trying to explicitly state is the uncertainties involved in these tests. One should not be so confident that okay, we have got this particular value and this is the final. It is not so. There are a lot of inherent uncertainties associated with each of these parametric values. Now, for engineering purposes, we need a design value based on which we can design various structures which are founded, or maybe design the foundation or various other applications. So, we need to understand that these are representative values and not really true values, and because of these hidden factors involved. And this has something to do with the loading rate, and we have already explained this. In actual condition, for drain condition to exist, the loading rate will be very low. In NC, you will be positive, and in OC it will decrease and tend to negative value. The Mohr-Coulomb failure envelope passes through origin for NC, this is important, and the Mohr-Coulomb failure envelope exhibit cohesive intercept for OC soil. You please note that I have used the term cohesive intercept. So, this does not mean that again it is a true cementation. There is a kind of value which you obtain because of the OC condition. This is associated with dilation. Mohr-Coulomb failure envelope is valid only in terms of effective stress, which is long term. Short term strength is only in terms of SU. Probably you will hear this statement once more when we discuss the next interpretation, which is phi d, because I find that, or I understand that this is very important to clearly get into your mind that undrained condition, the strength is mostly in terms of SU. Phi t, that is the total strength parameter which you obtain from the total stress, does not have much relevance with respect to Mohr-Coulomb failure envelope. Okay. So, that is all for the interpretation of consolidated undrained test. We will see about the interpretation of consolidated drain test in the next lecture. I again request the participants to be patient, those who know these particular concepts very well and those who have been taught these particular concepts very well. For them it may look like it is getting repeated, but for me these particular aspects are extremely important for all the participants to clearly understand this, so that the understanding of the subsequent modules will be easy. So, that is all for now. Thank you.